What if you fell into a black hole? 4,300,000 suns. That's the mass at the center of our galaxy, packed into a region smaller than the orbit of Mercury. We call it Sagittarius A star. In 2022, for the first time, we photographed it. Not the black hole itself. You can't photograph the absence of light. What we captured was its shadow. That photograph took over a decade to make, and it needed more than one telescope. No single dish on Earth is large enough to resolve something so far away and so small. So scientists linked 8 radio observatories together, from Hawaii to the South Pole to the mountains of Spain, and synchronized them down to a fraction of a billionth of a second, using atomic clocks precise enough to turn the entire planet into one Earth-sized virtual telescope. They called it the Event Horizon Telescope. For years, the raw data was too massive to send over the internet. Hundreds of terabytes had to be physically flown on hard drives to a supercomputer for processing. What came back after months of work wasn't a photograph in the usual sense. It was a reconstruction. A bright ring of superheated gas bent around a dark, silent center. The first image any human being had ever seen of the edge of a black hole. 26,000 light years away. Close enough to study, far enough to be safe. Tonight, we're going to pretend it isn't. Here's the part that surprises most people. Far enough away, a black hole is boring. Its gravity behaves exactly like any other object of the same mass. Swap the sun for a black hole of equal weight, keep your distance, and Earth wouldn't even notice. It would just get darker. The danger isn't the mass, it's the crowding. All of that mass compressed into a point means you can get closer to it than to almost anything else in the universe. And distance is what protects you. So you drift closer. Closer than physics usually allows a person to get to that much gravity. And gravity starts keeping score. It doesn't pull on you as one object. It pulls on every part of you separately, hardest on whatever's nearest. Your feet, leading the way down, feel a stronger pull than your head. Close to a black hole, that difference stops being trivial. There's a name for what happens next. Spaghettification. Scientists picked that word themselves, which tells you something about how seriously the field takes its own horror. Picture it happening to you, second by second. At first, nothing. Just a faint ache, like lying on a mattress tilted too far. Then your feet begin to outrun the rest of you, pull downward, just slightly faster than your hips, your chest, your head. You'd feel yourself lengthen, the way your spine stretches after a long flight, except this wouldn't stop. Blood would rush toward your feet. Your joints would strain first, then your muscles, then whatever holds your bones together. Long before you understood what was happening, your body would already be losing an argument with gravity. Pulled apart, not by heat, not by force in any direction you could brace against, but by the simple, patient fact that your feet and your head were no longer close enough to be treated as the same object. Here's a twist almost nobody expects. The bigger the black hole, the gentler this is. Fall toward a black hole just a few times the sun's mass, and the stretching kills you thousands of kilometers before you reach the point of no return. You never even make it inside, but fall toward Sagittarius A star, 4 million solar masses, and you'd cross that boundary completely intact. You might not even know the moment it happened. That boundary is called the event horizon, and here's what unsettles physicists most about it. There is nothing there to feel. No wall, no flash, no line in space you could point a flashlight at. Cross it, and the space around you looks exactly like it looked a second before. Locally, nothing has happened, but to anyone watching from a safe distance, you never arrive. Your light stretches, reddens, fades. You appear to freeze at the edge, forever approaching, never quite crossing. Two accounts of the same fall, both correct. Neither one lying to you. There is no version of this story where an outside observer and you agree on what happened, because you're no longer living in the same universe of now. Past the horizon, something stranger than death happens to geometry. Toward the black hole stops being a direction you could turn away from. It becomes more like a direction in time, the way you can't turn away from next Tuesday. Every possible path left to you, every choice, leads to the same point. Physicists don't call it a place you travel to anymore. They call it a moment you can't avoid. That point is where our best theory of gravity gives up. General relativity predicts infinite density there. And when a theory predicts infinity, that's usually not a discovery. It's the theory telling you it's out of its depth. What's actually there needs a theory we don't have yet. One that finally makes peace between gravity and quantum mechanics. Every physicist studying this will tell you the same thing, and it might be the most honest sentence in the whole subject. We don't know. There's a black hole like this at the center of nearly every galaxy we've ever imaged, including the one you're sitting in right now, 26,000 light years from where you're hearing this. It isn't coming for you. It isn't going anywhere. It's just sitting there, doing what it's done for billions of years, holding the one place in the universe where our physics runs out of road, and daring anyone to go find out what's past it.